नमस्कार दोस्तों, मैं दीपक वर्मा। Today we are going to learn how to process SAR data using the Sentinel 1 toolbox Snap. In this processing, we have three steps. In the first step, we will prepare data by downloading the images and selecting the subsection according to our area of interest. And in the second step, we will apply radiometric calibration and filter application, in which we will reduce speckle effect, and then we will apply geometric calibration, and in the last step we will use pixel thresholding to generate map, and then we will end this processing. We have to download SAR data using the link given in screen. I will give this link in description also. We have to download GRD HD data, that is level 1 data. To download the SAR data, type here ASF vertex. To download data, we have to set search parameter like search type. We have to select geographic search. In dataset, we have to select Sentinel 1, and area of interest. Area of interest we can draw with this geometry draw. Select box draw. Left click, we will draw a box, and then again click left. In this way we have selected our area of interest, and then click in filter. Here we have to select date of acquisition, so I'm going to select July 1st to July 31st. And file type, we have to select L1 detected GID HD data. Polarization, we have to select VV or VH polarization type. Direction, we have to select descending direction, and then click search. We will find some images over our selected area. To see the image, just click in zoom to screen. So here we can see the detail of our image like polarization type VV, VH, and flight direction, that is descending. Then click add to download. So according to your area of interest, click here add to download, and then log in with your user ID and password, and then go to downloads. Data that you have selected, just click to download. Save the data according to your desired location. After the data download, open Snap software and import your downloaded data by left click in file option, and then open product, and go to the your saved location and open. So here we can see that our data uploaded in Snap software. We can see metadata and vector data, and the band combination that this file contains. Click in the amplitude or band, we can see the image that we have downloaded. We can see that this file contains amplitude and intensity in VH polarization and VV polarization, and we can see our image location in the world view window. If it is not appear in your system, to go view and tool windows, and just click in world map. So after some time, when it is completely load on your system, you can see the location of your downloaded image. Actually it is inverted image. As a sensor acquisition type, you can see here flow path of stream is inverted, but after the processing it will take their original position. So in the next step, we have to generate RGB image. So click in the first image, and then right click open RGB image window. So here we have to select intensity, like for the red color we have to select VV polarization and green VH, and for blue we have to select either VV or VH, and then click OK. Here you can see RGB image, where you can differentiate between the feature like water shows the dark appearance and vegetation show in green. After this step, we have to reduce our file size to ease in processes. So we have to perform subset step for this. So to subset this file, just go to raster, then subset. So here in this window, you have to give the coordinate at the start x, start y, and end x and end y. So according to your area of interest, just give x and y, and then click OK. Then you can see one of image added here with the name of subset, same band like amplitude, VH and VV. So just close this window and double left click in this image. We have selected some part of original image to reduce the file size, so it will take less time to process. In the next step, we have to calibrate our image with radiometric calibration and geometric calibration. So to perform the radiometric calibration, we have to go in radar, then radiometric calibration, and click in calibrate. Set all the parameter as it is, run. When the process complete, third image automatically added here. Close this window with the name of. In the new band after the calibration, we will see the changes in the image. It is darker than the previous one, and radiometric calibration we have to perform because of error due to a signal loss in propagation and non-uniform antenna pattern, different in grain, saturation, and speckle effect. Now we have to remove the speckle effect. First select to calibrated file, then go to radar and SAR utilities, and then click multi-looking. In multi-looking, we have to set the parameter like according to that radar beam split in multi-look. So here we are selecting 5. We are dividing radar beam in 5 look, and then click run. After the process complete, fourth image add with the name of ML means multi-look. Same speckle reflection we will perform with speckle filtering like single product. So here we have to set filter type and moving window like 5 by 5, 7 by 7, or according to our choice. So I already perform speckle reflection with multi-look, so I'm not going to perform speckle reflection using the filter. So open image after the speckle reflection. This image is smoother than the previous one. We can easily see the difference. This granular structure called speckle effect, and this effect is smoother in this image after the reduction of speckle. After this step, we have to perform geometric calibration. So select fourth image, go to radar and geometric calibration, train correction, range Doppler train correction. Click geometric calibration perform with setting some initial parameter like any types of deformation of shape corrected with the reference of this digital elevation model. Here automatically selected SRTM 3 second digital elevation model. So leave all the parameter as it is and click run. After the train correction, close this window and another fifth image with CLMLTC has been added in your product explorer window, and just open sigma naught VH and we can see it is train corrected. Now we can see the image that is aligned with their original position as shown in world view. After that we have to calculate dV decimal value using this sigma naught. To calculate this, right click in sigma naught VH and go to linear to or from dV and click yes. So one of bandwidth sigma naught dV added. Similar process for the VV polarization. Now we have decibel value. Decibel value, it is a back scattering that is recorded by the sensor. Now open these dB value and we can see the difference. VH has more feature detail as compared to VV. So with the use of pixel info, we can see the pixel value or backscatter value for every pixel. Like here for the water, it is showing minus 24 dB value, that is correct value for the water, and for the land area it is showing near to 16 or 10. Now we have to calculate the value for water and for land to generate a map. To do this, click in color manipulation window and go to slider. Here we have histogram, so here we can see two peak, one for land area and second for the water area. So just adjust these value to differentiate between the water and land part, and same we can see for the VV polarization. So in the VV polarization, the threshold value is minus 17 or 16, and in the VH polarization threshold value is 21, near 2021. So generate the map. If in your system this color manipulation window is not visible, so go to view tool windows, and by this toolbar you can add a color manipulation window into your main window. Then we have to calculate water part and land part. To do this, we have to we have to make this image by binary image. To generate the binary image, go to raster, band math, then select here fifth number image, and here edit expression. Here write this formula, 255 into sigma VH less than 7. For VH we have 20 negative 21.78, close and OK. Okay. By this expression, white part is water area and black part is land. In the same color manipulation window, go to table and set land edge green and water area edge blue. So this is the binary image, and similar process we can perform for the VH polarization also. The VH polarization slider, go to raster, bandmath, edit expression 255 into VV less than 17.49. Okay, so this is the binary image for VV polarization. To change the color, go to table, and for the land part green, and water part this. Thank you. We can also import this image as KMG file for the Google Earth Pro. Export SAR data format, other UH KMG. Give the location. Thank you for the watching video. We will meet soon in the next video. Thank you.